Hi, I'm Ms. Hall, and this is Lesson 84, Two-Way Tables Using Probability. Finding conditional probabilities. You can use conditional relative frequencies to find conditional probabilities. Example 4. A satellite TV provider surveys customers in 3 cities. The survey asks whether they would recommend the TV provider to a friend. The results given as joint relative frequencies are shown in the two-way table. A. What is the probability that a randomly selected customer who is located in Glendale will recommend the provider? A. I have a conditional probability here. Okay, that given the customer is in Glendale, they will recommend the provider. So we're looking for yes, given Glendale. That's the conditional probability we're going to try to find. And we'll use this two-way table. So we're given Glendale. So I'm simply focusing on this column. That means the denominator is going to be 0.29 plus 0.05. And given Glendale, that they will recommend the provider is 0.29. And so when I rewrite that as a decimal, I get approximately 0.853 or 85.3%. That a customer who is located in Glendale will recommend the provider. B. What is the probability that a randomly selected customer who will not recommend the provider is located in Long Beach? B. So I want to find the probability given no that they are in Long Beach. So given no, that is going to be my denominator, the sum of all the conditional relative frequencies in the row no. To how many of those are in Long Beach? And that is 0.04. And that is approximately 0.33, which is 33.3% chance that selecting a customer who will not recommend the provider is located in Long Beach. C. Determine whether recommending the provider to a friend and living in Long Beach are independent events. So before we can answer that, we need to know the probability of an event and the probability of an event B given A is the key formula. We're going to be comparing the two probabilities here. If the probability of event B happening is the same as the probability of event B happening given that A has happened, then they're independent events. So if true, then independent events. The fact that A happened did not affect the probability of B. However, if this is false, if the probability of B is not equal to the probability of B given A, then we have dependent events. So in example C, event B is Long Beach. So the probability of living in Long Beach, and we're going to compare that, determine whether recommending the provider to a friend and living in Long Beach are independent events. We're going to compare that to the probability of Long Beach given we're recommending the provider yes. So you see that our B event is Long Beach and our A event is yes. The probability of living in Long Beach, we can add those two together, 0.32 plus 0.04 is 0.36 or 36%. And now the probability of Long Beach given yes. So given that it was recommended, the probability of living in Long Beach. So I have to add up all the probabilities of saying yes, all the conditional relative probabilities, plus 0.27 plus 0.32, and Long Beach is 0.32, and this is about 0.36 or 36%. So we are comparing 36% to 36%. So since those are the same, this yes given, did not affect the probability. Therefore, these are independent events because the probability, how would I write this? The probability of Long Beach is approximately, it's not exactly equal to, there's some rounding that needed to happen, but it's approximately equal to the probability of Long Beach given yes. Therefore, we have independent events. Example 5. A jogger wants to burn a certain number of calories during his workout. He maps out 3 possible jogging routes. Before each route, he randomly selects a route and then determines the number of calories he burns and whether he reaches his goal. The table shows his findings. What route should he use? We're going to begin by reorganizing this information in a two-way table. Actually, it already is in a two-way table. I'm going to make a new one. We're going to record the joint relative frequencies. So we're going to stick with goal or not goal. And I'm going to begin with the numerators. So goal on route A is 11. And then not goal on A is 6. Goal on B is 11. Not goal is 4. Goal on C is 12. Not goal is 6. And then to find the total number of times he recorded, I'm going to add up all the numerators, and those are all the jogs he went on, which is 50. So the denominator is going to be 50 for each entry. And then we'll calculate the relative frequency. So 11 out of 50. I'm going to put an equal sign because it's exactly 0.22, 0.12, 0.22, 0.08, 0.24, 0.12. Now with this information, I need to answer the question, which is which route should he use? In order to figure that out, I can't just compare these the values in column goal, because he didn't run the same number of times route A. He ran 17 times, route B 15, route C 18. So he didn't run those the same number of times, so I can't just compare those values. What I need to do is now compare the conditional probabilities. So given that he ran route A, what is the probability that he met his goal versus the probability of goal given he ran B versus the probability of goal given C. Okay, so given that he was running route A, which happened 0.22 plus 0.12% of the time, he met his goal 0.22, which is approximately 0.647. Now, given that he was running route B, which is 0.30, I can add those up. I added 0.22 plus 0.08, and I get he met his goal 0.22% of the time, and when I divide that, I will get approximately. I have to round, so I'll use the approximation symbol, 0.733. Finally, with C, The denominator is going to be 0.36. The numerator, his goal, is 0.24. Approximately 0.66.7. Let me not put it as a decimal and a percent at the same time. 0.667. And so which route should he use? Well, the route where he's most likely to reach his goal is route B. So the probability that he reaches his goal is greatest when he uses route